webinar. Today, we're going to talk about Java testing in the real world. We're going to feature JUnit, Mockito, and test-driven development made simple. So the first thing is, what is unit testing? Unit testing is testing the smallest unit of code. An example would be testing a method within a class. What is JUnit? JUnit is a testing framework. It allows you to verify that your code behaves correctly automatically instead of manually running your main method. What is Mockito? Mockito is a mocking framework. It allows you to fake dependencies so that you can test the class without actually running expensive external operations. An example of expensive resources includes a database, for example. Other examples include REST APIs, file systems, various email services, and payment gateways. Let's define what test-driven development is. Essentially, it's where you write your tests before you write the code. So it flips normal coding upside down. In normal coding, you write a code and then you test it. In test-driven development, these are the steps. You write the test and let it compile. You watch it fail. Then you write just enough code to make the test pass. Once the test passes, you refactor the code and generalize. And this is called red-green refactor. The red is when the tests fail. Green is when the tests are passing. And refactor is actually the most important. That's when you refactor and generalize for various scenarios. What are the benefits of test-driven development? It forces better design. It prevents over-engineering. It automatically creates documentation, and it produces loosely coupled code. However, in the real world, we do not use pure test-driven development. Because in practice, if you think about it, pure test-driven development, which is writing a test before every line of production code, would slow the teams down, especially when the requirements are unclear, changing, or exploratory, which is most of the time. The teams instead, they use pragmatic TDD. They write tests around stable business behavior and critical logic. So basically, they write tests so that when we refactor our code, we feel more secure about refactoring the code, knowing that if something breaks, the test will catch it. But we skip strict red-green refactor for work on the UI, prototypes, integration, and evolving features. Before we finish, we have to know when to mock behavior versus when not to mock. So you want to mock expensive operations such as databases, REST APIs, external systems, email services, and payment gateways. But we don't mock collections because collections have already been extensively tested and proven. We don't mock POJOs or DTOs. We don't mock simple calculations, and we don't mock our pure business logic because that's essentially mocking the object you're testing. You don't mock the object you test, you mock behavior. Now for a brief demo.